Um, Hello, hi everyone. We have Victor here. We're live now.
Let me see what is happening with my camera. Looks like it disconnected for some reason. Yep, now we should be back. All right, and it's not doing whatever it was supposed to do. Let me try to see if
Yes,
I can do something about this.
take your time. Take your time.
All right,
Yes,
let's see if I can switch back to normal camera. Um, Okay, so we're gonna stick to bad camera that works rather than
no problem.
into
No
the
problem. No
camera
problem.
that doesn't. How are you?
Yeah. Thanks, Victor, for joining my podcast. I'm really excited about it. I'm really happy that we've met finally. So, guys, if you can confirm that the connection, network, camera, sound are okay. If you can drop the comment, I'd be grateful. Um,
Do we following
oh,
comments somewhere
yes,
in?
yes,
Yeah, I see. I
yes.
see. We can see the comments that's coming. Hey, YouTube, welcome.
Okay, so today I think it would be a very special day that I'm having or hosting Viktor Gamov, one of the top speakers in the world about the data streaming, Flink, and he's a principal developer advocate at Confluent. And also he's the author of Kafka in Action. Last but not least, I've learned Kafka streams using Spring from Victor, following his
Oh,
videos on on Confluent YouTube channel. So yeah, uh, I'm so excited that I'm having you, Victor, today. I think we have lots of things to discuss about Kafka, data streaming, Flink, and lots of things in between. Um, if I missed anything, please you can join to introduce yourself. So if I missed anything, you're welcome.
no, I think you covered everything greatly. Yes, my name is Viktor Gamov. I work as a principal developer advocate at Confluent, founded by original creators of Apache Kafka. We do all things stream processing and data streaming platforms, and I work here as a the community and developer advocate to, talking to the larger community of developers and bringing all the goodies of stream processing.
Before actually joining into the core topic of the session, how you can give us a nutshell about how is the typical day of a DevRel advocate working in company like Confluent?
I can give you a real answer. I can give you funny answer. So the funny answer would be, I wake up. I wake up in my fancy hotel room, getting a fancy breakfast, and after that, going for doing the all things advocacy. But as you can see here, I'm in a fancy hotel room right now. My work involves some part of the travel. So I go in. To see developers where they are. I'm meeting local communities. Sometimes I travel for conferences and also meeting with customers. That's one of the things that I also love for my work. And well, partially, I also working on the content creation. I'm running this live stream called Streaming Frontiers on Confluent Developer YouTube channel, working with the bigger team of developer advocates to create contents, code snippets, examples, which everyone can find at developer.confluent.io. That's the place for all to learn all things streaming and stream processing, Flink, Kafka, what have you. And probably that would be the most um, the most important part of this presentation, it's developer.confluent.io. Like if you're just starting, or you looking to implement certain patterns, or you're starting to learn something about the Confluent Cloud, that would be the place where everyone can go and learn. I also helping to create a program for our events. We do have this year we're going to be 3 events about data streaming and AI called Current. We're already 2 events in. We did this in March in Bangalore. We did this in end of May in London, and one is coming in November November. I need to check the dates. Coming in the October timeframe in New Orleans. So if you're interested to be surrounded with the data streaming enthusiasts, please join us for Current New Orleans. It's going to be awesome.
Perfect. I think it's really nice to have you, so we can dig deeper into the data streaming world. But sorry, before jumping into the data streaming, let's discuss, or if you can shed the light, what's the problem with the batch processing or the normal batch processing? Why the shift has happened, especially over the past maybe 5 years? The shift from batch processing has shifted, or the mindset has shifted to events-based data in
I'm
motion.
wearing this special T-shirt today, so don't be a basic batch.
I don't know that you're wearing this T-shirt, so
Yes, don't be a basic batch. This is a very good question, actually, Karim. And it's always good idea to level setting of what kind of problem we're solving, right? So like we're doing things about distributed stream processing and data streaming platform, but what kind of problem we try to solve? And actually, we're solving. Maybe some people would say that we're solving the problem that we of our own creation, but I don't think it is entirely true. The world is not created, or things that happened in the world and things that we're trying to implement in the system that will be somehow model from real world are not represented in batch. Things are happening in the constant stream of something happening. This occurrence of certain I'm trying to look for better word that will replace word events, but certain occurrences of something is much more easier or much more natural to model in the sense of set of events rather than set of, I don't know, like files, batches, and all these kind of things. And those occurrences, those events, they happened in never-ending fashion. We have in our conversation, we're saying some words, and those words we cannot change. So they are naturally immutable. And things that if you want to change something, so I said something, I cannot change whatever I said. But what I can say something to amend my previous statement. I said something, and after, oh, I'm sorry, let me get back and explain this differently. So those things much more naturally can be described in event streaming platform or data streaming platform. The events in real life, it's the events in the system. They occur in real time. Those are immutable, and the things that you can do with this. Same with the data. Every business, every system that we designed and build aims to be represent some part of real life of the business workflow, real life of some sort of I don't know, if you're building a retail system or you're building like healthcare system, these things, they're much more natural to be described instead of events. But what we found in the past, if you've been here for the last 20 years, we started on the wrong foot, in my opinion, especially when we were limited by technologies of our time, and we were trying to describe the things in the real world in the form of, like, first of all, it was like entity relations and everything. We tried to put everything in the format of like tables. After that, we had this object-oriented approach where we have objects, and also we need to describe the interaction with these objects somehow. All those things work on, in my opinion. And again, I've been this for a while. Maybe I already have a PTSD of and professional deformation of the things, but I feel like this the ways how we design the system using entity relations and tables, and after that, when we try to get the picture, we will need to execute the joins and things like that. We were taught that our the database or like data system should avoid duplicates, so that's why we have like this third normal form of the things, and in order to get like a simple view of everything what happened, you need to perform like multiple joins and all these kind of things. Doesn't sound familiar to you? Like, have you done something in the past?
Yes, and lots of these kind of challenges I've faced over the past maybe 10 years when I started to move to the data world, maybe 9 or 10 years ago. The mind shift between having the operational world or operational environment and the analytical environment, and having the only components that understand or can link between these two worlds, the batching system or the batch processing technique, that by time became very limiting to the business to grow, to find business opportunities. So yeah, and actually, to be quite honest, it wasn't only about fancy decision making. It was about even very basic actions, like the in the retail business, the customer in the mall, and I want to send him an instant offer while he's walking around in the mall, not after 3 hours from leaving the mall.
Exactly.
So event streaming became very evident, not only from technological perspective, but mainly was the business driver who initiated this kind of shift, I think, from my perspective.
This is like you talk about this the batch in specifically, so I want to also address it. So when we're developing these different systems in the past, and specifically when we were developing or designing our business use case around tables and different things, we usually in the past end up building one big monolithic application, and only way how we can say the bridge between operational place where our users usually live, right? And we care about individual transaction because we care about individual records and databases. We had to implement the things with, ETL jobs that will move the data from our operational place to somewhere where our like analysts and the people who needs to write a report, build reports, and getting some of the insights in the bigger story. So in operational state, we care about individual records. In analytical state, we care about actual story behind this data. Say we care about individual transaction when we capturing credit card transaction, but in analytical space, we care about story like how much money we spent last week on the groceries. That will involve more like transactions from the last year, and after that you're slicing and dicing it based on dimensions, saying like you need to find the category for the groceries. After that you need to perform aggregation, you have a window within the the last week and things like that. And these systems like these ETL jobs, and these were also designed around the batch thing, because we were waiting until we finish our business day and we get the data out of this. And you were absolutely right when you point out that it's not the case anymore, because these decisions, these stories that we can get the data from, we need to make those stories more relevant. Like you don't care about last week. You want to know, say, okay, you performed some transaction on and you want to react on this transaction, maybe suggest some of the coupons, so your customer you can upsell your customer with some of the data. So events naturally transformed the business from like batch oriented things when you need to wait until the certain cut off, to the point where we actually don't need to wait, or we cannot wait because we need to make decisions right now. So you probably heard about this, since we're talking about ETL, but now we have a streaming ETL, and more interesting that with years of developing different systems, we came up with a ton of legacy systems where they work great. They work great. They help our businesses. They make money, and we cannot just all of a sudden just decide, scrap it and start from scratch, because it takes a time. And in order to kind of like serve this same use case, moving data from operational state to analytical state, different techniques came up. So, for example, if you take your database and insert something in database, it actually creates an event. You will be surprised. We're talking about this, like I'm trying to make a point that databases are bad, and designing the systems using tables, it's not very nice way, but surprisingly, the creators or like developers of database, they actually knew this, because inside the database, what things that happened is actually happens. Events happen when you insert something in a table. There would be new event that will be written in this like a very special thing called transaction log. And it turns out this thing can also be used to implement this ETL jobs. It has a different name. It has a name of change data capture, because change happen on database on the lower level, and we can actually grab this change.
I think there are 2 points. I think discussion might span more. I know that we're tight on time, but I hope that we might have more time for today. But I think there are 2 points that I would like to mention. The data modeling, it might be a little bit deeper point, but I think the data modeling, one of the showstoppers for modeling or building an ERD or a data model for the operational database versus the analytical world. I think this disconnect make the move or the shift really hard. But when it comes to model the data as events, I think it will not be exactly the same event will be used here and there, but I think it will be modeled around the business, more around the business, which make things a little bit closer when a transaction event has been fired from the system. So eventually the analytical model will look for the data points that representing this transaction. So I think, again, it will get us back to how the business is modeled. This one thing. And the other thing is the CDC, or how the database is being built. It's in the core, the event based and the concepts of events or taking actions based on events. And I think it's really important that we're getting back to basics. We're not inventing a new technology, we're not inventing a new paradigm, but it was built in the core of the database. Yes. So let's move on to the next part about Flink. I think in order to set the expectations also for the audience, we jumped into the discussion, which is really interesting. We'll discuss mainly about Flink concept architecture, the use case and its usage, and most important of and what's mostly important about this session today is getting from your experience, Victor, about the use cases, the real use cases when using Flink, how companies build their own streaming systems, how they move from legacy to streaming. I don't think it's a blink shift could happen. It will take lots of time and also lots of things other than technical perspectives. So let's start with, if you can give us brief about Flink, the evolution of Flink, the differences and comparison between Kafka streams, and maybe something like KSQL.
Yes, this is a very good point. A couple things where we didn't touch yet. We transformed everything from thinking in terms of like batches and records into thinking about events. And now we do have this perfect system, maybe far from perfect, but system that works. Apache Kafka, that's the system where we now capturing events, we're storing our events. And more importantly, it's not simple like a messaging where you consume the message and message is gone. There's a the persistence aspect of this data. So data will be available for Kafka to replay. There is, some people would say, some people would argue, there's really nothing like special about the getting data. Okay, so you read the event, you're doing something with this event, and after that, you move on. And there are two types of things what you can do with those events. Things that require or some memory or knowledge about the past, and things that don't require. And this is where we go into kind of what we call the stateful versus stateless stream processing. In the beginning of Kafka, there are some systems that were, or people were trying to use the systems that were designed for batching or performing like a batch computations, and they still will use this with Kafka. And one of the examples would be how the Spark transformed from better batch, transformed from handling better batch processing into what they called micro batching. So essentially, it still will be, batch naturally because the system was designed to be the batch system. But it feels like, okay, we're going to be chunking this in the smaller amounts, or we can figure out how we can, distribute data in our HDFS the way that we can read this a little bit faster than the job, than the batch job. That will appear, like a stream processing. With stream processing, actually, the difference between the micro batching and stream processing is that it's a little bit to the question from the Nomad Coyote from the YouTube is like, we in the stream processing, we always doing with one event at a time. It's never micro batch, so it's only one event at a time. It's very important, and because when you're performing this on top of batch, performing computation on top of batch, you're building some sort of projection one way or another, like select blah, blah, blah from table. That's your projection. You're getting, like, if you, from a little bit on the mathematical background of relational math, that is the foundation of our SQL databases. And we kind of like are creating some sort of like a net where we're pushing data from, and only data that we need will stay here. That's projection. With stream processing, we actually we have a topology that we push event through. So it's a difference between how we look into this one. Now, when we interested to just do simple filtering, simple transformation, it's easy. You create the Kafka consumer, you do something, and after that you have a Kafka producer, you send it back to Kafka or send it to somewhere downstream. Now, everything will be fun and games until you need to deal with something like a state. So that's why stateful processing is important. You need to run aggregation. You need to remember what happened on the previous step, because again, you're doing one event at a time. Like what happens with one event, how this event will affect the overall result back. That's the question. That's a very important question. And that's why instead of using traditional tools like Spark and doing micro-batching, we need to come up with new tools. And the community went through different ways how this can be processed. Like Apache SumsUp was one of the first examples of doing this. Community inside the Kafka, they took the experiences that they were involved in building SumsUp as well. Similar people and same people were involved in building this. Decide, okay, we need to have something like a library that allows people to process things. So they come up with Kafka streams that perform stateful and also stateless stream processing. You can do transformations, you can do filtering, all these kind of things, but also you can have computation where you can run aggregates, you have results, and Kafka streams provides the way how the state would be stored. But the Kafka streams, it is a system that has a very intimate connection with Apache Kafka. And turns out not everything rolls around Apache Kafka. And surprise, surprise, even though you with Kafka Connect, you will be able to virtually bring any data source inside your Kafka pipeline. But for many people, it also will be cumbersome because in this case, you need to maintain an extra infrastructure for Kafka Connect, run the connectors, find the connectors, develop connectors sometimes. Flink, on the other side, it is a general purpose stream processing. So again, it's also a stream processing system. We're not dealing with micro batches, but remember this. We're going to return this in a second because Flink is far more powerful than it might look on the first side. So Flink has a great integration with Kafka, but it is not absolute necessary component. You actually can bring data inside of Flink directly from database. There's a whole set of sub-project inside of Flink called Flink CDC that allows you to tap to those CDC things like change data capture systems, like capturing the transactions that happened on database. But we at Confluent, we investing a lot of time and effort to build kind of like stream processing with Kafka and Flink and inside the cloud. Now, Flink also, general purpose result doesn't have to be written back to Kafka. Like with Kafka streams, you only read from Kafka and only write back to Kafka result. With Flink, it's absolutely not necessary. In Flink, you will be able to use whatever connectors, whatever sync and source connectors. You don't have to use a Kafka at all. You can get, you can even run batch processing with Flink. That's the beauty of the Flink, that it creates unified API from perspective. It's a system that you write in your programs. That's why there's like APIs. And in this system, you actually can perform batch process with Flink, and you get the files, put them, have a connector that will read the data from file, perform this in Flink, and send back to files. And that's why Flink, it is for Flink batch process, and this is the twist that you didn't expect. Batch process is just one of the corner cases of stream processing, because it looks like a batch as a finite, the bounded stream of data, because it has a beginning at the end. Flink was designed kind of from vice versa. You have a Spark that was designed from the batch system, and after they tried to blend stream processing in the micro batches. Flink designed from stream like first mindset. But hey, if you have a bounded stream, not a problem. We can also serve this as one of the corner cases of our stream processing. Yes.
But what I'm using Kafka maybe almost 10 years ago. Why the shift has happened? Flink has been there for many years. It's not a new technology that's came up in the past couple of years. But why Kafka ecosystem or Kafka maintainers started to look into Flink as the rising star for streaming, especially now or over the past 2 years?
Yes, this is a very good question. And the answer here, it's also lies in this idea of stateful stream processing. Kafka streams, KSQL was the system that was designed around Kafka streams. So Kafka stream is a library. It's a library that exists and you put inside your application. It gives you lots of like, you have a Lego blocks. And with Kafka streams, you actually build very powerful data application, data-driven applications, stream processing applications, but it still requires you a lot of like a tinkering. It's not like you're buying, the set of Death Star or your set of Millennium Falcon, and you have instruction how to do this. It's more like you buying a set of like different bricks, and after that you need to figure out what you're trying to build. It gives you like a fantastic foundation. It gives you fantastic artifacts to build, but you need to build stuff yourself. One of the ideas was, okay, what if we can use Kafka streams as an engine to build system, what we called like a streaming database. And for the streaming database, we can have like, I'll give you like three categories that you can say that, oh, this is system is streaming database or not. So first of all, streaming database needs to operate on some high-level language. SQL. That's turns out to be the most common denominator for many people. Like you said, you use Kafka for 10 years and probably use some of data systems even more. And every time where everyone will try to invent their own query language, come up with something like, okay, so there's YAML, there's JavaScript, and any like MongoDB people who write the queries using the JSON notion. Everyone realized that, and yes, SQL is not ideal, but it's still going strong since 1992, and it is quite familiar for many people, or at least like today, you can ask any LLM to write your SQL, and with the very good chance you'll get pretty good results right out the way, because there's a huge kind of experience on this. Now, so SQL, that would be used as a language to manipulate for things. Your data streaming systems needs to be first-class citizens. Kafka, Kinesis, Pulsar, whatever. And third thing is that requires storage, because you're writing queries, you have materialized views, you have ability to not to reprocess those. You want to have ability to query those materialized view, or maybe even update this materialized view with continuous query. And KSQL was approach that we built at Confluent to build this like a first streaming database, like a streaming database that will include all three components. And we use Kafka Streams as a framework to build this system. Each query that you execute with KSQL will be translated into Kafka Streams topology. And with this approach, with approach of SQL, we gain quite the success on building this like general purpose stream processing with the language that many people kind of like know and what to expect. But the situation with KSQL is very similar with Kafka Streams. It has a very, very, very tight connection with Kafka
Streams.
And even with Kafka, you get data from Kafka, you're getting data, you're setting data to Kafka, and materialized view, the concept of this, how you can query this view, it's also stored inside the Kafka. And KSQL has a certain limitation that came with this, so that's why like scalability architecture is very tightly to Kafka consumer groups. But Flink, on the other side, since it's a general purpose system, it doesn't have its own limitation that's similar to how we have with Kafka Streams. Flink is a stateful system, so we can also figure out how we can maintain all these things. And Flink also has a sequel. There's a project that allows you to write your stream processing jobs using SQL. And this is the point where you ask question. But Victor, does it make Flink as a streaming database? And that's your cue.
Yes. I think it's really a nice wrapping answer for starting from the normal streaming to Flink, passing by Kafka, Spark streaming, and the other platforms. But I think this also very aligned with Kafka maintainers and Confluent mindset that we need Kafka to be open and integral part for external systems and external components, rather than just using Kafka closed components or to be tightly coupled with Kafka. We can have kind of wrappers or sensors that can integrate with external world and push the data to Kafka and pull it out of Kafka as if you're not very coupled with Kafka ecosystem, which is really, really eye opener on. And this is one of the things that I really like about Kafka and the ecosystem that maintaining Kafka. It's very visionary about how the data evolved over years. I've been using Kafka 0.8. I started from 0.8, so how the evolution is happening, how the maturity of the ecosystem is happening, it's really eye opener. And this assert that Kafka would be here for a while, not only supporting the applications, not only supporting the microservices or data streaming, but also the next era of AI and agentic LLMs. And we will get to this maybe toward the end of the discussion. Let's move on to the use cases, Victor. I There are two parts maybe we need to shed light on. The first part is legacy systems. Right now, we have millions of systems built with the old mindset, especially businesses built on rigid technology, rigid mindset. The culture is different, something like the banking or the financial institutions. Uh, some of them are still using mainframes. So, from your perspective or from your experience, how the shift could happen for such enterprise or corporates, given that the use case is really important. It's not a luxury or luxurious move. It's really important for the business to grow and sustain. How do they do the shift?
So this is a very good question. And in the world of application development, in the world of any data system, there is a usual cycle of things. And based on my experience, based on the things that I've seen in industry, this period usually around 5-6 years. Something would change, or system either will continue evolve, or it will evolve the way that in after 5 years it will not represent, initial idea, because it would be evolved so much. It will be rewritten multiple times. It will be re-implemented in order to meet demands of the organizations, of business, and ever-changing demands. But there's some use cases that are still fit very well. So that's why the fraud detection is a kind of like a playbook example for every data system that the people trying to implement. Okay, so let's implement fraud detection using batch process. We can't do this. Now we can implement the fraud detection using the streaming data. We can definitely do that. That's the kind of like systems where they will actually benefit from implementing using streams, implementing using like event-driven approach. But some use cases, they would be, net new use cases to implement because some of the things were not not possible to implement with the batching approach. Again, some of the transaction processing and the speed and sheer scale of the number of transactions that needs to be processed. If we're talking about the financial industry, real-time alerting, that's important things. You already mentioned this in the very beginning, how the streaming would change the way how we interact with our customers, how we interact with our users. In the past, marketing campaigns that will suggest you a new discount, they need to go through the pile of orders that you executed, and based on those orders, they need to find the ways what would potentially would be interest of you, and like a real-time recommendation, all these kind of things. Not the real-time recommendation engines. I remember the times when after you purchase something, and couple of weeks after, you'll get email, hey, you purchased something, maybe you would be interested in this. And I already moved on. I don't really interested in this type of thing. So for me, it's already past news. But now, like with the real-time insights, and kind of like make a decision based on whatever, even like you moving around website, we're capturing clicks, and depends on which page you were, and you were poking around certain elements, we can make a decision that, okay, you may be interested in something, or you click around to see, and immediately you can get the text saying, hey, we noticed that you were eyeballing this one. If you think that the price would be an issue for you, how about we give you 20% discount? So those things create more complex and more reactive experiences for the users. And maybe I was like, I never thought about this, but hey, let me purchase this one. So it's definitely, those use cases will definitely speed up the revenue generation for this case. recommendation engine, they say,
Yes.
I brought this up. You finish watching a movie on Netflix and you really excited about this movie, you really like that, and you would go and start reading reviews and saying like what would be very similar, but you don't need to do this anymore because Netflix will have your recommendation right after you finish this movie. It will give you personalized recommendation, and those things actually use Flink in the backend because it's constantly analyzing things, what happens here. And Netflix is a big user of Flink. They have a huge case study where they were talking about how they would store this, information about recommendations inside the Flink huge storage, because it's a stateful process that you
Yes.
need to get information from your previous runs, previous things what you watched at the
But
Netflix.
when it comes to the use cases are really evident and clear. But when it comes to the actual move, I'm a company X, whether I'm in the streaming business or retail business or banking industry, and I'm sitting in the past and I need to move or do the shift. Is it about tech? Is it about culture? Is it about caliber? Is it a mix of all these items? What is the showstoppers for organizations to start adopting the streaming and how they could start?
Um, I think one way or another, in this age of our technology, every organization will turn into some sort of like digital organization,
Agree.
unless you have kind of like mom and dad shop that makes cookies. But again, still, like if you make a cookies and you want to grow your business, you want to go online and kind of advertise yourself. So what I'm trying to say, like virtually any business is digital business right now. um, it will require changing mindset to the things, because some of the things will change the way how we deal with it, and we were discussing this throughout this talk today. How we change the mindset from looking at the tables and um, build complex joins when we want to have a report and all these kind of things. The streaming ATL and the data systems definitely changed the way how the people would, um, the big change would be, again, I've already spent the years in this space, and for me, when I'm talking about operational store, it's shifted from traditional relational database into Kafka. Like everything that happens to the system will be captured in Kafka first. If you would, I don't know if you use LinkedIn and if it's popular in Egypt and Cairo. LinkedIn,
Yes, it is.
everything that happens in LinkedIn will generate event. You go into update your profile, it will generate event. You go to add me to your network, which you definitely should. You go
We
in
are here connected.
into checking someone else's profile and saying, yeah, like congratulations with new job, it generates event. This is their operational state. Big Kafka event system, they were not writing this into database. Kafka will hold this information. And after that, based on these events, they now can build multiple use cases that on the one hand would look like a real-time experience on the website, for example, who viewed your profile,
Mhm.
or the programmatically create your newsfeed, because they know what everyone is doing in your network because all events are captured in Kafka. Now, extracting this data, extracting this story is more like analytical story, but it'll give you look into how like your newsfeed would be formed in the real time based on events that other people were doing, because other people updating their profiles, they posting something like that, and now it will give you personalized view.
Data is always
Same
moving.
thing
Yeah.
with, yeah, exactly. And it's a you can have this experience and you can get this, the weeks after, but engagement with a platform would be much lower because people need to return to LinkedIn once in a while. Now, I spent LinkedIn more this time than I ever used because of this, real-time experiences. I know that things happened in my network, and it is in time. So
It's instantaneous. Yeah.
big mindset change from how you were thinking about your operational state and your Kafka operational state, and also this data would be delivered to analytical state. This is what we were doing, say for example in Confluent. We're trying to provide the much easier things for analytical state. You captured all these events are in Kafka, and now we can represent those events in the form of a table that can be query with Flink, as a matter of fact, and you can start building these experiences right away because you already have this data. You don't need to move this around. You don't need to have an ETL. You don't need to have a CDC because it's already there. And this is kind of like a big mindset change, and we're going there. Vendors already embrace this. Multiple vendors that were, traditionally, take your data warehouse system. They now support the Kafka as a kind of like a streaming ingestion. The whole transformation of how we can deal with this analytical state and how our, the data lake that were historically don't care about the difference between the data lake and say like a data warehouse is that it's more like in data lake we just getting data from somewhere and store it, and we will figure out sometime in the future how we're gonna read this. So that's why like it's kind of like a schema on read. So we need to only figure out the format of the data only when we need to query this.
Which by time will most probably turn into a swamp.
Exactly. That's yeah, you stole my quote. That's I usually like to say. The problem with the data needs to be, the data needs to be used. The data needs to be used to create those insights. Otherwise, it will become stale and no one gonna use it ever, and it will become a data swamp. Exactly right. And the biggest problem was, again, ETL in the middle, like how we can move data around to one place to another. And what we're trying to solve here by like representing Kafka data in the form of, say, iceberg table is to give ability to use this data right away. Don't wait for ETL job to be configured, or you don't need to have any other like CDC tool to move data from your data lake system, which already decoupled. Your storage and your compute and data lake system is decoupled already because you store things in format that are suitable for storage. And only when you're ready to query this with your kind of like, what's the name? For this type of systems, we now use not ETL, but ELT. You extract data from the target system, you load this, and only when you need to read this, you will perform transformation. So that's why it gives you flexibility on using different, say, query engine or different the compute functionalities and things like that. So
yeah, we have a question. Maybe it's related, so we can take it. That's from Nomad. How does a large enterprise perceive the transition from classic Kafka and ETL binding to Flink? It sounds like replacing a large number of systems with a single monolith. Is there any resistance?
I don't think it's actually replacing large number of systems with the single monolith. So Flink is also allows you to implement use cases gradually. It's not like one things will replace all. Like I said, existing systems previously they exist, they're already working, and the ways how we can integrate this is changes from ETL where we're moving data around to the point where we're using like CDC to create a change of events, and we can gradually replace those systems in the future. And Flink is not only tool that you have to use. Still Kafka Streams. I would make a point that Kafka Streams is still perfect solution for event-driven microservices. The Flink, it is quite a complex system to integrate with existing frameworks. If you're writing like a Spring Boot microservice or Micronaut or whatever is the Quark is. Those systems, like I'm a Java guy, so I apologize if people offend by not naming their favorite framework.
I'm a Java guy.
Same thing with like Python. There's Kafka Streams influence a framework called Faust that is a Python framework, and it also can be used inside your the Python microservice. Flink requires some skill, and many organizations will come to realizing this eventually. Flink. Some people might experience a little bit of flashbacks from Hadoop and Spark work past, because it is very similar on architecture side of things. You're running cluster, you're submitting jobs, and you need to control your resources. You need to control how different tasks or different jobs will be executed there, and how they would use certain resources in order to perform this type of jobs. So it's definitely more difficult than that happens in the past. But I think it's a future-proof technology. Flink implemented a lot of knowledge and experience from distributed systems of the past, in order to say, like, implementing distributed snapshot. Flink has this concept of distributed snapshot, in order that one of the nodes will preserve current state of computation. Time to time, Flink nodes have to save the state somewhere in the file, but this needs to be performed in a coordinated way, in order this snapshot would be consistent. So when the system will restart, it will not introduce any kind of like a break-in data or bad data because of the data inconsistency and things like that. There's like huge work around this, and Flink done this type of things right, in order to run this at scale and the bigger things. So it's definitely will introduce its own like challenges, and the Flink community is actually trying to address some of them. For example, every time we're talking about state, it is different. It's a really difficult conversation to have, especially in the cloud native world, when everyone's like, okay, some systems might not have local disk anymore, and how you want to solve this. And say in the Flink 2.0, which was released earlier this year, and continue to work on the updates, they introduced the concept of disaggregated state store, so that your state can be stored very similar how it's done in, say, like data lakes. Your state can be stored in the object storage in the cloud. So it really doesn't matter if your local system that runs one particular job has a disk, because this state will be stored somewhere in object storage in consistent form, and your cloud provider will be responsible for application. So there's like, I'm going into like very like technical details right now, but in general, there are challenges that involve implementing this, but those challenges are both on solvable on organizational layer, but also solved in some of the technical aspect.
Yeah, actually, I need to ask you a question, Victor, about what you've mentioned. So let's say I have the client-facing system that will take some events, or push some events to Kafka, and I need this system to interact to a group or an aggregated events happened in a short period of time. So you mentioned that it would still, for microservice communication, Kafka Streams would be your stop shop. But if I want to query or get the last 3 events happened in the last 5 minutes window, for my back end application that will take the action and send the notification for the customer, do you recommend, from design perspective, is it better to build this as a Kafka streaming application and store the event or the final result in a table or something like this, or the application to query or Flink in the back end to do this processing and push a final event to Kafka topic that this back end listening to. Is the
This is very good.
question clear?
Yeah. It's actually a very good question. I last the current London, I did the presentation about kind of like what's the difference or how you would position yourself Kafka Streams versus Flink, and I did this in the very details, and it depends. It depends on the scale. Always.
Yes.
Kafka Streams allows you quickly prototype, and you can build the service, and you can do some of the things. But in the Flink, you can also run this, and you can have a like decoupled system where the things were happened it will land in Kafka. Flink takes those, reprocess this, and after that you can push it directly to say like some sort of table or like a hot cache that will feed your front end for your application. I did this. I will leave we don't have a time for a demo, but I will leave a link that you can share with your
I'll put in
subscribers.
the
I did a
YouTube.
presentation earlier this year at a conference called Kotlin Con. Depends on it. There's not much of the Kotlin. I tried to kind of introduce Flink for Kotlin audience, and I was trying to build something with their framework called Ktor that is quite popular
Yes.
microservice framework. And I use this approach where I show that how the Ktor can read the data directly from Kafka to feed kind of like a real-time alerts or a real-time feed. In the background, I have a Flink job that will generate a feed of delayed flights and delayed flights information based on the kind of like some of the information of the departure time and actual departure time, or like a projected departure time and the actual departure time, scheduled departure time. And I use this approach as exactly as you said. So in this case, my front end was feed from particular table, and Flink job would read the data from Kafka, will calculate these delayed things, and would place this inside the database that will be used to feed my real time. So Flink can be used in any architecture. Only the question is how, like, if you want to build the quick and dirty things, and Kafka Streams will allow you iterate faster because it's just a library and you're building apps faster. Flink will give you a little bit of headache at the beginning because you need to figure out about architecture, how you deploy the jobs, how those jobs need to be updated, and state management and things like that. But at the end of the day, once you will get this through this kind of initial learning curve of the Flink, you will be much more better off with the Flink on the long run, because you will be faster implementing this use case. Again, that's your data stream API, that's your table API, that's your SQL. Like you can, your analysts can come up with this particular use case that you can solve with one SQL line that you can easily deploy, versus you don't need to write a whole new application. So Flink gives you flexibility, but it will, keep in mind, it's not like silver bullet. It's not something, it has its own learning curve. That's why we have a developer.confluent.io where we can learn all things, how to start with Flink. That's why we have a Confluent Cloud where you can, we can take care of some of the infrastructure bits, and you can focus on, and you can all focus on actual implementation of the thing. So the answer is always depends. I'm here not to give you answers like directly, but I'm here to educate and give you general direction so you can also make a decision that works. Because some things can work today, but tomorrow it's not like you make a decision today, you have to stick to this decision until the end of your days. No, different tools came up. Different tools came up every day, and you don't have to be kind of like a single-minded with saying that, oh, we're gonna use only, I don't know, Vim for the end of my days, and we're not gonna use Emacs, and we're not looking into Visual Studio Code, and not gonna look into JetBrains or things like that. There's always tools for the job.
Yes, actually, this was the answer that I was looking for, that it depends, and this will take us, since we're just a couple of minutes if you can. The last question: what are the advices, or what is the advice that you can give for data engineers, software engineers that are building a streaming system? And let me, if you don't mind, that I think one of the most important things taking from your answer is that it always depends. It's not about the technology. It's not about the buzz or the hype happening in the ecosystem about using a specific technology. It's all about your mindset, understanding the architecture, understanding the problem at the hand, and you need to mm, use your skills as an engineer to build the right solution. There is no single approach to solve the problem. There are multiple approach, and might be all of them are correct, but it depends on the use case. What is the advice that you can give for software engineers or data engineers working on building data pipelines?
I think the answer would be always stay curious, stay constantly learn things, because the things are changing right now. It is one can argue it is the most confusing space, especially data streaming right now. There was an article titled something like, data streaming is most like a confusing space right now, but we'll keep investing this. We still live in the age. We didn't talk about AI. How come in 2025 we didn't even talk about AI and how the streaming actually will, in my opinion, would help to like feed a lot of this kind of like AI use cases with the real-time
If
lags
you
and kind
have
of.
if you have few minutes and would like to shed light on this, it's fine. If not, maybe for the next live.
I think that would be a good opportunity for like some follow-up discussions where we can do in the past based on the feedback from your community. If they want me to get back, I'm well happy to do this and talk a little bit more about AI. But in general,
Sure.
yes, it should keep learning, stay in touch. I know for many people it can be kind of a very unsettling, and people would be worried constantly that they make a wrong decision. There's no wrong decision right now. Everyone has their decisions, opinions. There's some use cases where the things can be implemented. Find something where you think it can be beneficial for business, but also educational for yourself, so you can learn along building the solution. No one. The Noah was not the master carpenter when he was building the ark. Like he learned along the way. He learned how to build this, and that's why with other things, with the technology, stay curious, learning things. Don't forget to check developer.confluent.io where they can learn things. Subscribe to the Kareem's YouTube channel. Subscribe to Confluent Developer. We're constantly posting some educational materials around Kafka, stream processing, Flink, Iceberg, all things. And I really appreciate this opportunity to speak to your communities and talk about things. You were a very nice host for this conversation, and leave us feedback. If you want to talk more about this, we can go more in details in the future.
Definitely, and most probably there will be a next live, if you don't mind, with more hands-on with Flink building CDC pipeline. And thanks a lot, Victor, for your time. Thanks a lot for shedding the light and sharing your knowledge and experience with the community here in Egypt and all the subscribers. So thanks a lot. Looking for the next time. Thanks.
Hopefully next time would be sometime in person. I'm looking forward to maybe travel to Cairo or maybe travel to some
Be
other.
my guest. You will have a very, very nice tour guide. Ask Olivia. You will be surprised about the program. So just decide, and we'll arrange it.
Sounds good. Yeah. Thank you so much for having me. Looking forward to see you. And my name is Viktor Gamov, and as always, have a wonderful day.
Thanks, Victor. Thanks all for your time, and let's meet the next episode. Bye-bye.
Bye.